Hey everybody, let's try some examples that include friction. So let's say there's a ramp, and then there's a box sitting on the ramp, and let's say you're given the mass and the angle. What's the acceleration of the box as it slides down the ramp? But now this time let's assume there's friction between the box and the ramp. So let's say we know the coefficient of kinetic friction and the coefficient of static friction. So let's say for sure this thing is sliding. So that means it's kinetic. So what's the acceleration? So step one, free body diagram. So there's weight. There's a contact force, which I can decompose. So the ramp is here. So there's a normal force, normal to the ramp. And then there's friction, parallel to the ramp. It's either this way or this way. And you just think, which way is opposing the motion? So if the block is sliding down the ramp, there must be a friction force opposing that, going up the ramp. And then it's sliding, so it's definitely kinetic. So I'll call it K for kinetic. Okay, so we should all have the same free body diagram. Now you pick coordinates. So my personal preference, it's sliding this way, so I'm going to make a coordinate going this way. Okay, now which of these is this angle? So let's go over that strategy again. Like imagine if you have a coordinate axis, horizontal and vertical like this, and then another coordinate system like this. And then look at the picture here, like this is horizontal and this is vertical. So you see how this angle's right here? So it's like taking the dashed coordinate system and rotating the entire thing clockwise by angle theta, like this. Right? And then look at this picture and look at this picture. That means for sure this is theta. Right? So the weight is at some angle theta with respect to what I called the y-axis. Okay, so now let's write Newton's second law, but decomposed. So in the x direction, that's positive and is opposite. So sine, opposite the x-axis. And then that's going negative. Equals mass times acceleration. Y direction, that's positive, that's negative. And this is adjacent to the angle. Okay, and then I know that the box is going in the x direction. There's no motion at all in the y direction, which means I can cross this out. Okay, and we know one more thing, that friction is proportional to normal force, right? And that's the coefficient of kinetic friction. Okay, so if we want to solve for acceleration, let's solve some math. So what do we know and what do we not know? If we're given the mass, the angle, coefficient of friction, then we don't know this. Okay, so 3 unknowns, but we have 3 equations. No problem, right? We can solve this one immediately. Right, so n equals mg cosine theta. And then we can put that right here. Right, so n equals mg cosine theta. Put that right there, which means mu k times n. Okay, and then we can take this and put it there. So that gives us I'm writing this equation right here. Minus Fk equals mass times acceleration. Okay, and then just divide both sides by mass, and we got it, right? Let's see, we can factor a g. Okay, so we got the acceleration as the block slides down the ramp with friction. How about a follow-up question? How fast is the block going when it's over here? Let's say it goes some distance d. How fast is this? Can do. Right, you think about, all right, all the formulas in the world. Looks like kinematics to me. This value looks to be constant. That's constant, that's constant, that's constant, right? This entire thing is constant. So kinematics for constant acceleration. And then it's asking about speed. So maybe you use the one that looks like this if it sounds familiar. Right? And then let's say you start at rest. So that's 0. This is that distance d. And this is that whole thing. And then just take the square root, and there you go. Okay, how about one more? A little bit different question. Let's say you put that block on the ramp, and let's say, I'm just going to make up numbers. And there's coefficient of friction, let's say we know the values. And you put that block on the ramp and you let go. Is it going to slide or not? Like say, right? Before you let go, you have to predict, is it going to slide or not? Can we figure that out with just this information? And it goes back, right? It's a free body diagram. So it takes a little bit of critical thinking. So it's like, okay, let's assume there is enough friction to keep it from sliding. So let's assume there's static friction. And then I'm just going to pick my coordinates the same way as the other example. And that means this is theta. Okay, so if we're assuming this is static, then that means it's not moving. So AX is 0. So think about it's like a tug of war. Going down the ramp is this much force, and then opposing that is this much force. So really what you're asking, is this enough? Right? Is there enough static friction to prevent the block from sliding? Okay, so let me write it like this. Down the ramp is this much. And then up the ramp is this much, which is max, at most. Right, so it's actually this inequality, right? It's less than or equal to this times this. And n we can get from right here. So n equals mg equals sine theta. I'll just write it. Right, so at most, max, it's this much. At most, right? Maximum. So this number has to be greater than this number. Is this number greater than this number? And then, right, this Fs is mu s mg cosine theta. Is that greater than this number? Well, we can simplify a little bit, right? Like mg, I can take cosine and move it over here. So is mu s greater than sine theta over cosine theta? We can check, right? Because we know the angle here. So you just check, like is, what number did I say? Mu s 0.5. Is 0.5 greater than tangent of 30? And then that's what you ask. Okay, and I just punched that in the calculator, and then that's 0.577, and you're like, nope. So there is not enough friction to prevent the block from sliding, so that means you put the block on the ramp, you let it go, it'll slide. Okay, all right, let's do some more examples in the next video. I'll see you on those.